Hello friends, welcome to Learning IT Jee&Neet. Today we are with Physics Basics Part 1, that is motion. And today we are going to study about the displacement, distance and velocity, average velocity, speed, average speed and acceleration, average acceleration and many more things. In this video we will only go for basic concepts and basic definitions in this video and some formulas we are going to know. And let's start with motion. And what is motion here is when a body is said to be in motion when a body is changing its position. Suppose a body is here, it is changing its position to here with time, along with the time. That means taking the time into the consideration, we are going from here to here, point A to B. We are changing our position. So it is called motion. And this phenomena is called motion. So we can write the definition for motion is when a body changes its position with the time is called motion. When a body changes its position with time into consideration, if a body changes its position, we call it as a motion. And coming to the relative term, that is opposite term to the motion, is rest. This is also simple. When a body does not changes its position with time is called rest. Do not change. They both are relative terms. And let's take some instances and some examples where we can know all this. And with respect to some points, some are in motion, and with respect to the other points, they are not in motion. And we will go for one example. Take an example as here is a road and here is a person standing. That let's name him as A. In a car there are two persons, that is B and C. This is car. They are going in this direction, and with respect to A, what is this motion here? B and C are in motion. Because the car is moving, so he thinks that they are also moving. So with respect to, take opposite case, that is B and C. With respect to B and C, A is in the motion. Because they are moving front, and here is a person standing there only. So with respect to, let's take in this example as with respect to B, C is in the rest. With respect to B, if he is seeing C, C is in the rest. With respect to C, when C is seeing B, he is in the rest. And when they both are seeing A is in the motion. When A is seeing B and C are in the motion. And we can calculate many of the instances, and we note a point that a body is in the rest in reference to one point whereas in the motion in reference to other point. These are the observations from this example. And now let's go to distance and displacement. First we'll go for distance, and along with this displacement and what is the distance? The definition of the distance is the actual path length covered by a body. And what is displacement? We have already learned in our 8th class about these formulas and all the things, but just we'll go for recap or recalling all the things, and that is the shortest distance. The shortest distance is called displacement. And let's take an example to understand. When we don't understand, we should go into our the real life situations, and we can understand it. So let's take an example here. Here is a point A, and a person is standing here, and at point A, here is the point B, that is school. Let's assume him as a school going boy, and he can travel, he can go from point A to B like this, and like this, and it is another one that is like this, a straight line. And what is distance and displacement here? Here it is displacement, and this is equal to distance and along with displacement. In this instance, distance is equal to displacement. Actually it is a shortest distance, and it can also be a distance. And how can we get this is when a body or a particle is traveling in a straight line, that instant we call it as a distance is equal to displacement. In that case we get distance is equal to displacement. And let's write this thing, that is distance and displacement. Distance is obviously greater than displacement, and in this case we have distance is equal to displacement. So this is the most important thing in our motion. Distance is greater than or equal to displacement, but displacement cannot be greater than the distance, and this is our observation here. And one more thing, that is when the distance and displacement are equal, that is when it is a body or a particle is traveling in a straight line and along with the same direction without changing its direction. If a body or a particle move in a straight line, that is equal to distance is equal to displacement. And let's go for another thing, that is speed and velocity. What is speed? Speed is the distance traveled by time taken. This is one of a formula of speed. And what is average speed? That it is defined as the ratio of the total distance covered and to the ratio of the total distance covered to the ratio of the total time taken, that is average speed is equal to total distance covered by the total time taken. So we can observe this like the total distance covered with the total time taken. The total time taken to cover the total distance is called average speed. And next we'll go for instantaneous speed. Let's go for instantaneous speed. It is defined as the speed at particular point of time, that is particular instant of time. Let's take an example to understand this. Here is point A, here is point B, and let us not take this example. We'll go for some of the original example, that is a real life example. When a person is going from hospital or office, let's say office, to his home, in middle of this let's take an observation, that is a person is traveled with average speed, that is average speed 60 km per hour. Let us say 60 km per hour to travel from office to home. So what is the instantaneous speed? We can know that in the middle of his travel or in the middle of his journey, where he could stop in travel traffic, or he could stuck in any of the traffic, or it would be a traffic signal, or it would be some road damage, and many of the instances will come here. But is he guaranteed with the traveling of the same speed, that is 60 kilometers per hour? No. At some instant of time, some point of time, the speed may vary. That is, at some point of time he may go with 60, or at some point of time he may go 20, or at some point of time he would go 40 kilometer per hour. So we are not guaranteed with the to average speed he is traveling, but we can know that at some point of time, that is it is 11 a.m. and it is 11:15, 11:20. At this point of time he is traveling with this speed, and at this point of time he is traveling with this speed. So at that instant of time he is traveling with that distance. We'll go for velocity. It is defined as the rate at which the position of a particle or a body changes, and its formula is V is equals to S, that is displacement by time taken. This is the formula of velocity, and let's go for average velocity. Same as average speed, but it changes to displacement. That is, it is defined as the ratio of total displacement to the total time taken. That is, average velocity is equals to total displacement by total time. And what are the differences between speed and velocity? Speed is a scalar quantity, whereas velocity is a vector quantity, and speed and the similarity in this is the units for speed and velocity is same, that is meter per second square and meter per second, kilometer per hour. These are the units of speed and velocity are same. And now let's go for acceleration, that is the last concept. Acceleration is defined as the rate of change of velocity. The rate of change of velocity is called acceleration. And what is, we'll go for some things, that is acceleration is equal to rate of change of velocity, that means initial position minus final position, final position minus initial position by t. Rate of change of position, that rate of change of position is defined as velocity, and this is total time taken. And average acceleration, we have a term, and average acceleration is defined as the total rate of change of velocity, the total rate of change in velocity also, or we can call, and by to the total time taken. Total change in velocity by total time is what we call as average acceleration. So there is instantaneous acceleration, and that is the acceleration at that instant of time is called average instantaneous acceleration. Is units, that is meter per second square or kilometer per hour square is the units for acceleration. And that's all for our today's video, friends, and see you in the next video, that is physics basics part 2, that is Newton's laws of motion. And thank you, keep studying, all the best.